Okay, so back with the second part of the quadratics video. So now we're going to look at using the quadratic formula to solve a quadratic equation, and let's just first write the standard form of a quadratic equation, which is x squared plus bx plus c, that's equal to 0. Now the quadratic formula states that x is equal to minus b plus or minus the square root of b squared minus 4ac all upon 2a. Great. So when solving the problems, you would just plug the values of b, a, and c in the formula and solve for x. Now the quadratic formula is normally used when the factors of ac, as in when you multiply a by c, and the factors of that product cannot add to give you the middle term, which is the b term, then you would normally use the quadratic formula. Or if the numbers in the equation are large and you would rather not worry about finding factors of a large number that can add to give you the middle term, then you can always go for the quadratic formula. Now let's just dive into a question. Now we have x squared plus 3x minus 4 equals 0. And as you can see from this question, let me make sure. Yes, this could be solved using the method of factorization, but for the purpose of this video, we're going to use the quadratic formula. Now x is equal to, and as I stated before, just plug the values in. It's like plug and play. So minus b, but b is 3, so we would put a 3 here, plus or minus the square root of 3 squared minus 4 times a, but a is 1, times c, which is negative 4. Great. And all that should be placed over 2a, but a is 1, so that's 2 times 1. Great. Now continuing, x is equal to minus 3 plus or minus the square root of 9 minus, now that's a negative 4 times 1, which is negative 4, and that is multiplied by a negative 4, which is positive 16, so that's a plus 16, and that's all upon 2 times 1, which is 2. Great. Now continue, x is equal to negative 3 plus or minus the square root of, now 9 plus 16, that's 25, that's all over 2, and we come to the top. Let's just use a different marker. Now can continue, x is equal to minus 3 plus or minus the square root of 25 is 5. Great. And that's over 2. Good. Therefore x is either equal to negative 3 plus 5 upon 2, or x is equal to negative 3 minus 5 upon 2. Therefore, if we simplify this one, we would get 1, because negative 3 plus 5, that's 2, 2 upon 2, that's 1, or x is equal to negative 3 minus 5, that's negative 8, negative 8 upon 2, that's negative 4. So x is equal to 1 or x is equal to negative 4. And that's basically what you do when you're using the quadratic formula. It doesn't get any more complicated. I'll just say that if there's a negative sign under the square root, if there's a negative value under the square root, then that's going to result in an imaginary, in a complex number. So complex numbers are done in advanced maths. So if you're not an advanced math student and you somehow run into a problem where there's a negative value under the square root sign, then that question is basically not for you. However, if you're an advanced math student, then you should know that your value for x would be a complex number. And I might go through complex numbers later on. Now let's just go through completing the square, solving by completing the square. Now let's just write what a perfect square should look like first. So normally a perfect square is set up like I'm writing now. So you have x squared, coefficient of x is 1, and you have plus bx, and of course the c term would be half the middle term, which is b over 2 squared. So usually that's how a perfect square is set up, and when we're using the method of completing the square to solve the problems, we're going to recall this basic principle. And okay, so let's give an example of a perfect square. That's x squared minus 2x plus 1. Good. So this expression is a perfect square. If you look closely, when you have negative 2, you get negative 1, and if you square negative 1, you get a positive 1. So therefore this is a perfect square. So now let's just move on to a problem where you have to solve by using perfect square, if you're asked to solve using that method. Trying to find a simple problem to start with. Okay, so let me use this problem. So we have x squared minus 7x plus 6 equals 0. Let's say you're asked to solve this problem by using the method of completing the squares. Alright, so first thing you would do is group the x terms. So let's just write them down like this. Simply keeping them to themselves somewhat. Now we need to get what's in the bracket in the form of a perfect square. So if you recall from above, when I said that with a perfect square, the n term, here the c term, would be half the middle term squared. So if we should half negative 7, that would be negative 7 over 2, right? So we're adding that, and that's all squared. So let me change this to a square bracket. Good. And of course plus 6. But remember now, initially we did not have this negative 7 over 2 all squared. So basically we have just changed the overall value of this expression by adding the negative 7 over 2 all squared. So what we would do to balance that is simply subtracting whatever this value is, and that's negative 7 over 2 all squared. So we added it in the bracket, come outside and we outside the bracket and we subtract it, okay, and that's equal to 0. Now what I didn't mention from the example given above, that with a perfect square this could be written as just x minus 1 all squared. Now the minus 1 it comes in when you half the middle term. Now when you half negative 2, you get negative 1, hence the negative 1 comes there, right? Also, if you should factorize this expression, you would get why this result comes up. Now let's just apply that same principle to this question. So basically we would have the x, and as mentioned up here, the negative 1 is half of the negative 2, so the value here should be half of negative 7, which is negative 7 over 2, and that's all squared. Great. And now we have, you write back our plus 6 minus, and if we should square this fraction, you would get 49 over 4. Good. Now when you remember, that's equal to 0, and now we want to simplify. We want to simplify this portion, so we would basically subtract the 49 over 4 from 6, and we should get negative 25 over 4, if my math is correct, which I really think my math is correct. Okay, let's just change the color of the marker. Now we solve, and we're going to transpose for x, so x minus 7 over 2 all squared is equal to 25 over 4. Now remember, this bracket is being squared, so in order to get rid of the square, we're going to square root both sides. So that's x minus 7 over 2 is equal to the square root of 25 over 4. Now we have x minus 7 over 2, that's equal to, alright, now when you square root a fraction, you should know that that simply means the square root of the numerator over the square root of the denominator. So if you should find the square root of 25, which is the numerator, that's 5 over the square root of 4. The square root of 4 is 2. Great. So now one thing that you should note is the square root of a number can either be positive or negative, right? Because if you should square negative 2, you would get 4, and if you should square positive 2, you would get 4. So the square root of 4 is a positive or a negative 2. Now, in a lot of cases, you're just going to use the positive square root, but for these problems, we use both the positive and negative. Now let's proceed to solving for x. Now x is equal to, and we're going to bring over that negative 7 over 2, so that's equal to 7 over 2 plus or minus 5 over 2. And it's safe to put the this number first and then the other number that we're going to add and subtract. So now solving for x, we'll have x is equal to 7 over 2 plus 5 over 2, or x is equal to 7 over 2 minus 5 over 2. And for both cases, 7 over 2 plus 5 over 2, that would result in a value of 6, or x is equal to 7 over 2 minus 5 over 2, that would result in a value of 1. So therefore x is equal to either 6 or 1. And we have just solved that using the method of completing the square. Now I'm going to do another problem where the coefficient of the x squared term is not 1. Now the problem we're going to use is 3x squared minus 5x plus 2 equals 0. Great. Now when working with these problems, first you would separate the x terms from the constant like before. Now what you would do after doing that, remember the square there, after doing that you would factor out the coefficient of the x squared term, because you want the coefficient of the x squared term to be 1. So therefore we would factor out a 3. If you factor out a 3, then what would be left in the bracket is 3x squared minus 5 upon 3x. Because remember, if you multiply 3 by negative 5 upon 3, then you're going to get back your negative 5. Good. And of course you put the plus 2 equals 0. Great. Now the next step is to make what's in the bracket a perfect square. And if you recall, for this to be a perfect square, then the c term here would have to be half the b term squared. So that's plus. Now if you half negative 5 upon 3, then what you would get is negative 5 upon 6. Forgot to use square brackets instead. Square brackets. Great. Now plus 2. Now here is the sort of tricky part. Now in the previous question we didn't have a coefficient out here. We didn't have anything multiplying the bracket. It was just 1. Good. Now in this problem we have something multiplying everything that's inside this bracket. So when we are subtracting the term we added here, when we are subtracting that term, we have to be sure to also multiply by what's outside the bracket, which is that 3. And remember, all of that is equal to 0. Great. So now we can write our 3 bracket. Now we can write it in the square form. So if you can recall, we have our x, and then we basically just write down half of the b term, which is this right here, negative 5 upon 6, and that's squared. Great. Now we have our plus 2 minus, now negative 5 upon 6, that is, when you square that, you would get 25 upon 36. Good. And remember, that is being multiplied by 3 equals 0. Good. Now we write back this part. Now, I won't be doing too much of these. I would make the video really drawn out, but I made sure to cover one where the coefficient is 1 and one where the coefficient isn't 1. Now when you multiply these two terms, 25 over 36, you would get 25 upon 12. Great. That's equal to 0. Now we need to simplify. Now we should note that when you subtract 25 upon 12 from 2, that is going to result in 1 upon 12. If you want, you can look over subtracting fractions, or subtracting whole numbers and fractions, just to get a refresher. Alright, now I'm just going to erase the top part so I can have some more space. Good. Alright, now let's continue solving. Now we need to transpose, so we'll have 3x minus 5 upon 6 all squared is equal to 1 upon 12. Now after doing that, we need to divide both sides by 3, so that's x minus 5 upon 6 all squared. Divide both sides by 3, the 3 there would cancel, and divide this side, you will get 1 upon 36, because you would simply multiply the 12 by 3. Divide both sides by 3, then what you would have in the denominator is 12 times 3. Now continuing, let me erase the rest of this. Now we have to square both sides because we're solving for x. Square root both sides. If you square root both sides, then you would get, and if you can recall, if you square root a fraction, that's just the square root of the numerator upon the square root of the denominator, which the square root of 1 is 1 and the square root of 36 is 6. And of course, remember now that it should be a plus or minus. See, it can be easily forgotten, but if you forget it, then you're losing a solution to the problem. Now we transpose for x, and we get x is equal to 5 upon 6 plus or minus 1 upon 6. Now all you have to do is just add, then subtract. X is equal to 5 upon 6 plus 1 upon 6, or x is equal to 5 upon 6 minus 1 upon 6. Therefore, x is equal to either 1 or x is equal to 4 upon 6. As I mentioned before, should be able to add and subtract fractions. Since the denominator of both of these fractions is the same, then you would simply add the numerator, keep the denominator, so it's 6 upon 6, which is 1. For this part, denominators are the same. Again, subtract the numerator, 5 minus 1, that's 4. So you would have 4 upon 6. You can leave it as 4 upon 6, or we can simplify it to get 2/3. Now that's all I will go through on completing this square. If you have any more questions on the topic that you would like help with, you could send it to me. I'll put my email in the video description, so you could email me the problem, or just if you could put the problem in the comment section, or just find a way to get the problem to me, and I will do my best to reply to you in a video. So thanks for watching. Please like, comment, share, subscribe, share it with your friends. It may help them, or just adds little more substance to what you have already learned. More information is never too bad, so just share the video so that I can reach more persons. So I just decided during this quarantine that I would try and do some videos, help people. So yeah, just share, like, comment, subscribe. Give me your feedback in the comment section. I'll see you in the next video. I may do an advanced math topic